All right, guys, here we are at last at IAC. This has not been an easy process, to say the least, but we've got Ariane 6 in the background looking pretty impressive, and it looks like there's going to be a hell of a lot of delegates and tables to stop by and visit. So let's get going, not waste any more time. Okay, guys, we are here with Oren Milstein of STEMRAD, and you may have heard about this. It was in the news a few months ago, a radiation vest being designed in Israel. Looks like you got other countries involved. Please tell us, how is this going to protect astronauts from, say, a coronal mass ejection?
Right, no, thank you, Jordan. Yeah, so this is the Astronaut vest behind us here, and it's to be worn by crew members venturing into deep space for the first time since 1972. So since the Apollo missions, we haven't had anybody beyond low Earth orbit. So over there, you're not protected by the magnetic sphere of Earth, so you could be exposed to the harsh elements of a solar particle event. So the vest is a form of PPE, protective equipment, that goes over your vital organs in your torso area, and in doing so reduces the chances of having any kind of effects due to radiation exposure, the most prominent effect being cancer down the road. So we selectively target susceptible organs for protection from the effects of radiation.
So I understand that you have one of these vests on the Artemis 1 mission. How is this going to tell us how well it's going to provide protection, given that there are no astronauts on board?
That's a good point. So we're sending a Helga and Zohar, two radiation phantoms packed with thousands of radiation sensors. One of them, Zohar, the Israeli counterpart, is going to be wearing the vest, while Helga, the German counterpart, is going to remain exposed to the elements. And we're going to have a comparative analysis of the dose readings upon return to Earth.
Poor Helga. What do you think? How much protection is this going to afford? What is success in your book when it comes back? What's going to be regarded as a success?
Right. So the best case scenario is that we have a solar particle event during the 40-day mission. But in the absence of that, we're going to see the reading during the passage through the Van Allen belts. And the energy of those particles is quite similar to a solar particle event. So we're going to be able to see the efficacy of the vest in shielding those solar particles. And we're expecting about a 50% reduction in effective dose, total effective dose of the body. And that would translate to a 50% reduction in the probability of cancer down the road.
Wow, that's fantastic. So, I mean, if we're combining these vests then with a radiation shelter or something like that, it sounds like we're eliminating a lot of the problems of deep space as far as radiation and cosmic rays. Would you say that's a fair statement?
I would say that's a fair statement for short duration missions, up to a few months. But looking at travel to Mars, we're going to have to find a solution for galactic cosmic rays as well. They are very penetrating and very difficult to shield. So if you're looking at a 3-year mission, in the absence of a solution for that, I think it'll be difficult to eliminate the option of cancer down the road.
Well, I am very, very excited about your results and what you get out of this. I think that this is a fantastic idea, and I wish you all the success in the world.
Thank you so much, Jordan. Thank you to all your readers and viewers.
Okay, guys, so here we are. We're looking at a fascinating machine here that seems to have something to do with lunar regolith, represented at the University of Krakow. Is that correct? And Forgive me, I only just met you. So once again, can you please describe what we're looking at here? And also, I think you had a pretty big achievement recently.
Okay, so we are a space team. We are a student club from AGH University of Science and Technology in Krakow. This is Tolrecon. It is project made for the Over the Dusty Moon Challenge, organized by Colorado School of Mines, and this is a project to transport the regolith from point A to point B. Basically, the rule was to build a construction that is really light, that will transport 100 kilograms in 1 hour. That will transport the material in 5 meters horizontally and 3 meters vertically. So yeah, you can actually see here just smaller version of our project, just to just we can show people how these devices actually work.
So lunar regolith is both incredibly abrasive and also electrostatically charged. So what did you do to deal with that problem with this machine?
Yeah, we try to reduce wear of surface of our conveyor by using the very special conveyor. It's pull rod conveyor. We move regularly very smoothly, with not disturb during transport process. We decide not to use the screw conveyor. The material is mixed all the time. We just very gently push material inside the tube. And the second problem was the vertical transport, and for this task we used bucket elevator. And our idea was to use one drive system for 2 conveyors. We can easy to change the speed, capacity of conveyors, but increase speed, but all the time we have synchronized work of both conveyors. You can see all system over there.
And what is the mass and volume of your machine? How large of a fairing do you need, and how heavy is it?
Okay, so as we know, it's important to make all the parts easy to transport on the lunar surface. So our conveyor can be easily packed into small space, and its weight is only 100 kilograms. So it can be also lower, and we can produce all the parts on the moon. We can make the profiles out of lunar regolith by
Philosophy in situ resource utilization.
So you're going to use in situ resources to manufacture even one of these machines, is that correct?
We hope so. We hope so. It's our target.
Wow, that is really fantastic. Now, I understand you won an award recently, is that correct?
Yeah, that's the only one which works. That's the only one machine that works this way. So we are pioneers in that area.
So in the future, let's say that we have a lunar mining operation of some kind. I mean, can this be scaled up to move, several metric tons in the future, or is this going to pretty much stay about the size that it is?
For sure, it's easy to scale this because it's a really working machine. Just scale is no problem. It should be a little bit bigger.
Fantastic. Well, congratulations, first of all, for your accomplishment, and I look forward to seeing your technology on the moon. Thank you very much. At this point in the video, I need to ask you guys a favor. I met, well, somebody I'd known for quite some time, but never face to face, a guy named Randy from a company called Spaceshipmania. He's the guy who actually made that Starship 3D model, 3D printed model rather, on my set, and also the alpaca model, and now he has his own YouTube channel, and unlike me, he's a real rocket scientist, and he explains the fundamentals of all of this stuff in very easy to understand lessons. He just started out recently. I'd like to see his channel succeed because I really think he puts out some quality content. It's linked in the description. Please check it out, like, and subscribe. Let's move on. Guys, I am finally here with HyImpulse. You've heard me talk about them a number of times in the past. I'm here with Paula Breda, who has generously decided to give me some of her time today. Thank you very much for joining us.
You're welcome. Thank you for being here.
So tell me, HyImpulse, it seems like you're kind of more on the small side of launchers, at least to start off with, and you're going to be launching from Saxavord, is that correct?
Yes, this is correct. So we basically have our mini launcher, which is competing, as you probably know, with other two companies in Germany, but several more companies and startups in Europe. So it's pretty challenging. However, we have the key of the green propulsion with us because we are developing a hybrid engine. And yes, our first product, before getting to the launcher, we are developing the sounding rocket, which is our demonstrator for the technology. And this is probably going to launch either from Saxavord or from Australia. So Saxavord is definitely on the pipeline.
Fantastic. So tell me about this hybrid engine. What makes it different from others?
Oh, the hybrid engine is a simpler configuration with respect to the liquid engines that you see, for example, from SpaceX or NASA. Everybody sees them. There is a very good example here. For example, you have Ariane Group with Da Vinci. You can just go there and see the complexity of the pipelines on top because you have turbo pumps and then you have to pressurize the system through them. In our case, we have liquid oxygen as oxidizer, but our fuel is solid. So we are using paraffin, which is basically candle wax, but with some additives on it. And this makes less complex because we lose one part of the complexity through the high pressurized system. Plus, the handling of the whole, throughout the whole process, the production, and also from the operator point of view is way more safe. And it's not exploding unless you ignite it.
Actually, paraffin is only a substance I became familiar with pretty recently. I mean, what led you to decide to go with this unusual solution?
We have a solid foundation on this. Our four founders had been working at a student group from the University of Stuttgart in Germany, and they've been researching hybrid propulsion since 15 years, 20 years about. So this is what they started. They had the student group at the University of Stuttgart, which is also close to the German Aerospace Center in Lampolshausen. And they had a test facility for small-scale engines. So in 2018, they developed, there was a competition, sounding rockets for students, and they developed a rocket which was 10 kilonewton of thrust. And with this, they won the altitude record of 30 kilometers. So this is why our four founders who were into this group, but also parallel working at the DLR, two of them, they decided to say, okay, so this looks nice for a startup as a business, so let's try to have it as a business and create our mini launcher. Because it's more competitive compared to the other launchers as we change the technology directly, so we can save more cost in the end.
Fantastic. Okay, this should be our last question. There's a philosophy of the types of components and parts that are used. For example, Isar Aerospace is using all composites, things they manufacture themselves. RFA is using off-the-shelf components from like the automotive industry. Which route are you taking for the components for your rocket?
Well, we tend to be independent, and we are trying to develop everything in-house. Of course, you're going to have some small components that are going to be bought off the shelf on the market, but the main engine, it would be the fuel grain, it will be made by us, and also the winding is made by us inside, so that we can be as independent as possible for the market, also for the materials. And we're also considering for the mini launcher some additive manufacturing as well, because it's very challenging also for our rocket. It's going to be a good one.
So in-house manufacturing, like SpaceX does, it's definitely follow HyImpulse and everything that's going on here in the world of European spaceflight. Thank you for your time.
Thank you. That was great.
Okay, guys, I am here with Orbital Outpost right now. You may have known them in the past as Space Villages. These folks came in 4th place with the whole NASA competition for a private space station. They actually tied with SpaceX on their concept. Please tell us more about your station.
Thank you. So we plan on having a modular space station in LEO. We're aiming at being at 500 kilometers altitude. So our design is a very modular and scalable one, where we have few independent parts where we repeat those parts over and over again to build a large space station. We plan on having up to 100 humans in space at one time, and each module can be independent of the other ones, so that different companies can have a module for themselves, or nations can have a module, and then each module can be different. So someone can have a research module, a manufacturing module, a habitational module. For example, if a hotelier company wants to come in, they could provide a module and run their hotel out of there, while we provide the infrastructure that they need, the power, the communications, the data, the station keeping, and such. We can also provide other services that are more common to space stations, such as hosting payloads on the nadir of the station as Earth observation. And the last thing that we're planning on doing is have an assembly integration facility where we can assemble large space structures for them. They send up the parts, and while it's connected to our station, we assemble it with our rendezvous service vehicle, which is our space tug, and put it all together. And once it's fully assembled, it can be separated from the station and go into the orbit that it chooses to have.
So it sounds like this is not just a space station, it's also sort of a stop-off point whereby people can do some assembling of their own. So you foresee this as kind of being perhaps a workspace or a construction site where other companies can build their facilities as well?
Absolutely. We envision having a space shipyard basically in space, where we can build it up and allow our clients to envision bigger projects that haven't been able to be done by building things that just don't fit inside one fairing at a time. They can just send up pieces and assemble it up in space for us, and we'll do it for them.
And how do you foresee that people talk about fuel depots a lot? Do you have any plans on that in terms of providing refueling, for example, for Starship or smaller spaceships?
Yes, we do have that envisioned. Right now we're deciding whether we want to provide that as a service, or some other companies have considered having their gas stations basically in space, and we would host that as a module connected to our space station. So they could have their gas station, and we provide the infrastructure that they need to have that station up in space.
Okay, we were talking earlier, what sort of launch vehicle, what sort of fairing do you require in order to send this thing up?
So we're going to require an 8-meter inner fairing. So at the moment, Starship is the only one that's capable of. However, we are agnostic. If another launcher comes in and has a fairing that size, we'll be able to look at them and decide if they can go in there. And then future station missions that don't require that large fairing can also be launched on other launchers as well.
So sometimes I ask the tough questions here. With that requirement, it means that you're really depending. Nothing else has an 8-meter fairing that's coming out right now. So do you have plans in case Starship doesn't work out that well to downsize this if necessary?
Great question. Yes, if Starship doesn't come out, then we can scale down our central module a little bit so that it can fit in New Glenn, which would be the next lower in there, which has a 7-meter inner fairing. So we can scale down a little bit, but we'd rather not do that. And I do have some confidence in SpaceX to be able to produce a Starship and make it successful.
I have similar confidence, to be honest. So is there anything else you'd like my viewers to know about your mission, about what you're doing?
One of the things that we want is to lower the price for space access for the future. So if a company wants to have not an entire module for themselves, they can also do a timeshare or a space share on the module themselves. That way they don't have to provide the entire station for themselves, and it reduces that cost tremendously for our clients.
Fantastic. Well, I'll tell you, I'm excited about this. So much commercial effort going into placing a permanent presence for mankind in low Earth orbit. I can't wait. Thanks so much for your time today.
Thank you.
So if you're keeping track, that is the third video that I have released coming from the IAC convention. If you've missed the other two about RFA and about Skyrora, you are missing some very, very cool information. Please check those out, especially Skyrora and the fact that they just picked up a 10-year SpaceX veteran. Don't miss out on that. And I've got more to come in case you're wondering why the hell am I showing you Sierra space footage right now. Well, it's because I did an in-depth interview with Sierra Space's president. Yes, the lady in charge. I got a chance to talk to her in depth about Orbital Reef, about the life modules, and that's coming up next. Please like, please subscribe. Also, please check out Randy's channel if you want to learn a lot more about the fundamentals of spaceflight and space science. This guy has just encyclopedic knowledge about it, probably because he got an education in the subject, unlike myself. And in the meantime, as always, stay angry about space.